Okay, so this video is going to be our day 11 video, our second day 11 video for Unit 3 of Algebra 2. And in it, we're answering this EQ here, deriving polynomial functions given the degree and the roots, right? So here in this example and the entirety of this video, we're going to work through these three problems. And from the given nth degree, the degree of the polynomial, um, and the x-intercepts, we're going to derive some function of x that's a polynomial. So to see what I mean, let's start with number one. So n is 3, so that means there's three solutions, roots, or intercepts, whatever you want to call them, right? So what that means is we've got 0 equals, or actually, we wouldn't have to say 0 because we're not solving for anything. We would just say, we'll just call this one f of x. We'll probably just call all of them f of x. F of x equals, well, if x is equal to positive 1 and x is equal to negative 1 and x is equal to positive 5, well, that means my linear factors associated with these solutions are going to be as follows. Okay, so we're just kind of working backwards. So that means f of x is going to come from multiplying out x minus 1 times x plus 1 times x minus 5, right? And this right here, well, we know that that's a difference of squares, right? So I know that that's going to become x squared minus 1. So that saves me a lot of time. Okay, and now I'm just going to FOIL. Okay, so x squared times x to the third, x squared times negative 5x squared, minus x plus 5. Okay, and there's no like terms for me to combine. So that means the polynomial that results, the third degree polynomial, right? It's a third degree polynomial, and we see that that's obviously the case. The third degree polynomial that results whenever we know that the roots or x-intercepts are x's plus or minus 1 and positive 5 are obviously going to be x to the third minus 5x squared minus x plus 5. Okay, and what is the significance of this? Well, if I throw that in a graphing calculator, and I just so happen to be prepared, and this is exactly what we got just now. If I throw that into the graphing calculator, we see that we get the exact same x-intercepts that we had before, namely negative 1, positive 1, and positive 5. So plus or minus 1 and positive 5. Okay, so pretty interesting stuff. So we're literally just given a little bit of information, and from that, we can find an nth degree polynomial function. Okay, so second example. So what if it's a third degree polynomial again, and its roots are positive 3 and 4i? Okay, so that means it's going to be a third degree polynomial like the last one was, except, well, if it's third degree, how do we only have two roots? Well, you'll see here in a second. So obviously, the linear factor resulting from an intercept of positive 3 is going to be x minus 3. So we have f of x is equal to x minus 3 times something. Okay, so this one is going to require a little bit of a special touch. I need to get rid of this imaginary unit I, right? Well, remember, I is the square root of negative 1. So if I just square it, right, it's going to become negative 1 because I squared is negative 1. Okay, so if I just square both sides, I'm going to arrive at, instead, x squared is equal to, okay, so 4i times 4i, that's going to be negative 16. Okay, and I'll break this down real fast. So 4i times 4i is going to be 16 times I squared. And we just said, right, I squared is going to be negative 1. Okay, so now this makes sense, right? We've got x squared when we solve this backwards, right, to get our factor the way we did here. We're going to say x squared plus 16 now. Okay, so from this, right, from that, we have 2, 3 intercepts or roots. Okay, so it still holds true. So again, I'm going to FOIL x times x squared, x to the third, right? So that makes sense, right? X times 16, 16x minus 3x squared, and then minus 48. Okay, so if we rewrite that in standard form, x to the third minus 3x squared plus 16x minus 48, that would be my f of x for that one. Okay, so if I have a third degree polynomial whose roots are 4i and positive 3, the resulting polynomial function would simply be x to the third power minus 3x squared plus 16x minus 48. So you're probably wondering, so we're talking about x-intercepts. What does it mean if the x-intercept is imaginary? So let's bring up our Desmos calculator again. And let's see if I can adjust the size of it a little bit here. Oh, of course I can't. Cool, I just closed it on accident. Oh, no, I didn't. Okay, let's see. Come on. Aha! Okay, I am the master of Desmos, sort of. Okay, so, well, no, I can't see. Okay, there we go. Okay, so I'm going to type in x raised to the third minus 3x squared plus 16x minus 48. Okay, so I enter that in. I should have 3x intercepts, right? But unfortunately, when I zoom out, no matter how far I zoom out, right? So I'm literally at 50,000. The x-intercept happens only at 3. So all that really means is I only have one real x-intercept, which makes sense because this gave me two imaginary or complex, what do you call it, intercepts. Okay, but there's still 3 there. Okay, so last example. So this one's a fourth degree polynomial, and its roots are 2, negative 5, negative 4, has a multiplicity of 2, which is basically a fancy way of saying that that root happens twice. Okay, so let's look and see what that means exactly. Okay, so let me erase and give myself some room because I'm going to need it. Okay, so what are we going to have this time? Well, I'm going to have x equal to 2, which is going to give me a linear factor of x minus 2. I'm going to have x equal to negative 5, which gives me a linear factor of x plus 5. And I'm going to have x minus 4, x equals negative 4, which is going to give me a linear factor of x plus 4, except it's a double root. What that means is it happens twice. So that means it's squared. Okay? So that means I have f of x is going to be equal to x minus 2 times x plus 5 times x plus 4, all of that squared. And I'm going to need to use my useful trick here for perfect squares, where I say that, a plus b all squared is going to be equal to a squared plus 2ab plus b squared. Okay, that's going to save me a lot of time, and I'm fixing to use that right now. So that is just going to give me x squared plus 8x plus 16. Okay, so that's what this guy is equal to when I FOIL it out, and that's going to save me a crap ton of time. Okay, so we've never FOILed anything this giant before. Okay, so what I'm going to do is FOIL these two, and then I'm going to multiply it all out afterwards and then combine like terms. Okay, so x times x is x squared minus 2x plus 5x minus 10. Okay, so we're going to combine like terms here. So we've got x squared plus 3x minus 10. All of that being multiplied, we still have this guy here. X squared plus 8x plus 16. Okay, so this is going to work like how we've done in the past. So I'm going to distribute each and every term into the other. So I'm going to erase some of this other crap that I don't need here and make sure I've just got plenty of room. Okay, so x squared times x squared, that is going to give me x to the fourth, because we're just adding the exponents. X squared times 8x, that's going to give me plus 8x to the third. And x squared times 16, that's going to give me plus 16x squared. Okay, then 3x times x squared, so plus 3x to the third. Okay, that's going to give me 24x squared. Okay, and this is going to give me 48x. Okay, and I already see I'm running out of room. Lovely. Hopefully this stupid nonsense will let me select all of this as one. Nope, it's not going to. Come on, bro. Let me move all this. Oh, cool. Well, at least I can do this a little bit. That's not helping. That gives me a little bit more room. Okay. So I'm going to have to switch colors here or else I'm going to start going cross-eyed. So now I need to distribute the negative 10. So that's going to be minus 10x squared. That's going to be minus 80x. And that's going to be minus 160. Okay. So now I'm just going to combine everything. So x to the fourth combines with nothing. 8x to the third will combine with 3x to the third, so plus 11x to the third, 16x squared, 24x squared, 40x squared. Okay, 48x. Oh, I left out some x squareds. Gosh dang it. Okay, I didn't leave out any cubes. Okay, so we've got 16, 24, that's 40, minus 10 is going to give me 30x squared. What's the matter with me? Okay, and then 48x minus 80x, that is going to give me negative 32. And then, of course, we're left with the minus 160. Yes, brutal. So, just a whole bunch of foiling, basically. So f of x is going to be equal to this fourth degree polynomial, namely x to the fourth plus 11x to the third plus 30x squared minus 32x minus 160. And its four linear factors are going to be these guys here. And of course, we know its x-intercepts are these guys. Okay, so like always, if you have any questions about anything, let me know. Otherwise, goodbye.